We will now show an example on how we can perform median polishing. We will use the data from the agricultural experiment discussed in the introduction earlier. Since we know that median polishing is an iterative process, we will just demonstrate how the first cycle is performed. We will first focus on factor A. The first step to estimate the effect of each level of factor A, denoted by alpha sub r, is to take the median of the C times L observations for each level of A. Since we have 3 levels of methionine, 2 levels of protein, 3 times 2 is 6, then we will get the median of the 6 observations from each level of lysine or factor A. Thus, we have these column medians. Next step is to get the median of the 4 medians and subtract it from each of the medians to get the initial estimates of alpha sub r. If we subtract it to each of these column medians, we will get these initial estimates of the effects of each level of factor A. And the median that we subtracted will be our initial estimate of the overall value. The next step is to adjust the data by subtracting the column medians to each entry of the three-way table. Hence, we have this. After this, we will now focus on factor B. The first step is to take the column medians. But before that, we have to rearrange the table so that factor B is now the column factor. This time, we will have 3 column medians since factor B has 3 levels. The next step is to center these column medians by subtracting their median to each of them. The result will now be the estimates for the effects of each level of factor B or methionine. And the median that we subtracted will be added to the first estimate of the overall value. Thus, our estimate for mu is now 256.25. Next, we will subtract the column medians to each of these entry and we will get this. Then, since we now have the estimates for the effects of each level of factor A and B, we will now focus on factor C. Similar to what we did earlier, we need to rearrange the table so that factor C is now the column factor. After that, we will take the column medians. Next step is to center these column medians. The result of the subtraction will be the estimates for the effects of each levels of factor C or protein. And the median that we subtracted will be added to the previous estimate of mu. Thus, we have 258.81 as our estimate for mu. This marks the end of the first cycle of median polishing. These are the estimates that we got after the first cycle. But from the remark, the process is usually continued until the medians that are taken out are almost zero. In our case, this happens on the 5th cycle, which means that we have to reiterate the cycle 5 times. On the next pages, we will just present the result after 5 cycles of median polishing are performed. From the third remark, we will defer centering until the last step of the iterative process. We will first get the sum of the column medians from each cycle before we center them. For the factor A or for lysine, the median of the sums of all the column medians is 250.16. This will be the first estimate for the overall value. And the results after centering the column medians would be our estimate for the effect of each level of lysine. For methionine, After centering the sums of the column medians from the 5 cycles, we will get these estimates for the effects of each level of factor B or methionine. And the median that we subtracted will be added to the previous estimate of the overall value. Thus, we now have 247.15. For protein, similar to what we did for lysine and methionine, we will first center the sums of the column medians after performing the 5 cycles. Then, the result of centering the column medians would be the estimates for the effects of each level of protein, and the median subtracted would be added to the previous estimate of the mu. Thus, our overall value would be 250.099. After median polishing, including the estimate for the overall value, we also have these effect estimates. Here are some examples of how we can interpret these results. First, among all the responses, the common weight gain in pigs would be 250.099. Second, our estimated effect for the 0.10 level of lysine is 1.8672. This means that when we add 0.10% of lysine in the corn diet, the weight gains in pigs may increase by 1.8672. Third, our estimated effect for the 0.25 level of methionine is negative 1.7681. This means that when 0.25% of methionine is added in the corn diet, the weight gains in pigs may decrease by 1.7681. And lastly, our estimated effect for the 14% level of protein is 20.25. This means that when 14% of protein is added in the corn diet, the weight gains in pigs may increase by 20.25. We can present our results in this manner. The cells that are highlighted with light orange are the residuals, which can be obtained after performing the 5th cycle. Or we could also use the main effects only model. The cells highlighted with orange are the estimated effects of each level of each factor. This is from factor A, factor B, and factor C. And this is the estimated common term. Using the data in this table, we can obtain the original data by the main effects only model. Using R equals 3, C equals 2, L equals 1, if we add the estimated common term plus the estimated effect of the third level of factor A plus the estimated effect of the second level of factor B plus the estimated effect of the first level of factor C and the residual, we will get approximately 275, which is equal to y sub 321. This is it for median polishing.